Hello, my dear students. Last class I explained about bearing capacity, Terzaghi's bearing capacity theory, and different formulas for C5 soil, cohesive soil, and non-cohesive soil, and also the water table effects. Let us see some problems on this. Numericals. Then you will understand better. Okay, so let us take this example. A square footing 2.5 meter by 2.5 meter is built in a homogeneous bed of sand of unit weight 20 kilonewton per meter cube and having an angle of shearing resistance of 36 degree. The depth of the base of the footing is 1.5 meter below the ground surface. Calculate the safe load that can be carried by a footing with a factor of safety of 3 against complete shear failure. Use Terzaghi's analysis. Okay, so this is the problem given. Now you have to calculate the safe load. Okay, to calculate safe load you require safe bearing capacity. Okay, to find safe bearing capacity you have to first find ultimate bearing capacity. Okay, ultimate bearing capacity, that is QF. Okay, from ultimate bearing capacity you can calculate net ultimate bearing capacity, that is QNF. Net ultimate bearing capacity QNF, that is equal to QF minus Q naught, or Q naught is nothing but overburden pressure, that is equal to gamma D. So QNF, net ultimate bearing capacity, is equal to ultimate bearing capacity minus gamma D. Once if you get net ultimate bearing capacity, you can calculate what is safe bearing capacity. Safe bearing capacity, that is nothing but ultimate bearing capacity divided by factor of safety plus gamma D. Okay, so these three things you should always remember. The first one is ultimate bearing capacity, that is different formula for different types of soils and different types of footing. Okay, there are four types of footing: square footing, rectangular footing, circular footing, and strip footing. Okay, so then you should know ultimate bearing capacity, that is QF, net ultimate bearing capacity QNF, that is nothing but QF minus gamma D. Next, safe bearing capacity, that is QS, that is equal to net ultimate bearing capacity divided by factor of safety plus gamma D. Okay, once if you know all these things, you can solve any type of problems. Now let us see, this is a square footing. So I have given different formulas for different types of footing. Okay, so for the square footing, the formula is QF is equal to gamma D NQ plus 0.4 gamma beta and gamma. Okay, now in this term, gamma is equal to unit weight, that is given 20 kilonewton per meter cube. D is depth of foundation, that is equal to 1.5 meter. NQ, what is this NQ? N gamma, this is the value of bearing Terzaghi's bearing capacity factors. This you have to get it from the table. I have given one table for different types of, for different 5 values. Okay, for that particular 5 value you have to take what is NQ and what is N gamma. So here this shearing resistance phi is equal to 36 degrees. So you have to take phi is equal to 36 degree. For that particular 36 degree, what is NC, what is NQ, what is N gamma? That three bearing capacity factors you have to take. Okay, and one more thing, here there are 3 types of failures. I have explained in the previous class, that is general shear failure, local shear failure and punching shear failure. Local and general shear failure we usually use. Okay, punching shear failure problems are very less. Now, for the general shear failure, you always remember, if the phi is always greater than 36 degree. If the phi is equal to or greater than 36 degree, you can consider the general shear failure. If phi is less than 28 degree, then you have to consider local shear failure. Okay, so the difference is that general shear failure, you can take directly the value of NC, NQ and gamma. But in the case of local shear failure, you have to take NC dash, NQ dash and N gamma dash values. And one more thing, in the case of local shear failure, that C is equal to 2/3 of C you have to consider. I mean C dash. Local shear failure, you have to consider C dash and phi dash. So C dash is equal to 2/3 of C and phi dash is equal to 2/3 of tan phi. Okay, these things you always remember. Okay, so now here this is general shear failure. How you can make out? Because the angle shearing resistance is 36 degree. So this is general shear failure. So take NC, NQ and gamma value from the table. So you will get NC is equal to 65.4, NQ is 49.4 and gamma is 54. But here this NC term is not there because this is a sand. So C is equal to 0. So the first term get cancelled here. So C NC that is not there here because C equal to 0 because here this is a sand. Okay. Now only two terms NQ and N gamma term. So this is gamma D NQ plus 0.4 gamma beta N gamma. This is ultimate bearing capacity. So net bearing capacity, how you can calculate? QF ultimate bearing capacity. Net ultimate bearing capacity is equal to QF minus gamma D. Suppose I substitute minus gamma D here, then what happens if you take gamma D outside, then it becomes NQ and here one gamma D is there minus 1 plus 0.4 gamma B gamma B and gamma. Anything you can consider. You can directly use in this equation, or once if you get this value, you can deduct minus gamma D. That can also be done. So in this problem, I use this formula. In the next problem, I use in the other way. Okay. So now here only I have used. So directly you can write QNF, that is equal to gamma D NQ minus 1 plus 0.4 gamma beta and gamma. Substitute the values. What is gamma? Gamma is equal to 20. Depth of the foundation or depth of the footing is 1.5 into NQ. NQ is 49.4 minus 1 plus 0.4 into gamma is 20 into beta, sorry not beta, width of the foundation, that is this is a square footing, so width is equal to 2.5 into N gamma, that is 54. Substitute, you get the simplify, you get the answer 2532 kilonewton per meter square. This is net ultimate bearing capacity. Now you have to calculate safe bearing capacity. How you can calculate safe bearing capacity? Safe bearing capacity is equal to net ultimate bearing capacity QNF divided by factor of safety plus gamma into D. QNF, that is 2532 divided by F, factor of safety is given 3 divided by 3 plus gamma is 20 into depth of the foundation 1.5. So you will get 874 kilonewton per meter square. This is safe bearing capacity. Now we have to calculate safe load. How can calculate load? The stress, you know, stress is equal to load divided by area. So the load is equal to stress into area. Here stress is nothing but bearing capacity. You can see this is a pressure kilonewton per meter square into area, that gives the load. So safe load. Now B square means area. This is a square footing. So area is B into B. So B is 2.5 into 2.5 into a safe bearing capacity is 874. If you will get what is the safe load. Okay, very simple. Main thing you should know all these terms. I hope all of you understood. Let us take one more example. the same problem, okay, previous problem only. What will be the maximum safe load? For example, 1, if the soil is loose sand of unit weight 16 kilonewton per meter cube and the angle of shearing resistance is 25 degree. Now the same problem, everything is same, only the difference is unit weight is 16 kilonewton per meter cube and angle of shearing resistance is 25. So now I have told if the shearing resistance or phi is less than 28 degree, you have to consider local shear failure. Okay, so local shear failure, what the difference between local and general shear failure? Local shear failure, you have to consider NC dash, NQ dash and gamma dash. So refer the table for 25 degree and take the values of NC dash, NQ dash and N gamma dash. Okay, now so from the table you will get, see the table I have given in the last video, NQ dash that is equal to 5.6 and gamma dash is equal to 3.2. Now everything is same, so substitute the values. The formula is the same one, that is this formula, gamma d NQ plus 0.4 gamma b into n gamma. So use the formula, substitute the values, or the gamma is equal to 16 here. Okay, substitute 16 and you have all the values, d and q dash and gamma dash, substitute, you will get qnf is equal to 161.6 kilonewton per meter cube. Once if you get qnf at ultimate bearing capacity, can calculate safe bearing capacity, that is equal to qnf divided by f plus gamma d. Okay, so substitute the values, you get what is safe bearing capacity. Once if you get safe bearing capacity, you can calculate safe load, that is nothing but area into safe bearing capacity. This is a square footing, so area is b square, 2.5 square into qs 77.87, so you will get 486.7 kilonewton. Okay, let us take one more problem. A strip footing now, 1 meter wide at its base, is located at a depth of 0.8 meter below the ground surface. The properties of the foundation soil are: gamma is equal to 18 kilonewton per meter cube, C is equal to 30 kilonewton per meter square and phi is equal to 20 degree. Determine the safe bearing capacity using a factor of safety of 3. Use Terzaghi's analysis. Assume that the soil faced by local shear. So in this problem, it is given that soil faced by local shear. So you have to consider local shear value. So what is the things you have to remember? You have to consider NC dash, NQ dash and gamma dash. And this is a C phi soil. So that value also changes. C is equal to C dash, that is nothing but 2/3 of C, and phi dash, that is also 2/3 of tan phi. That values you have to consider. And this is a strip footing. So for the strip footing, the ultimate bearing capacity is given by CNC plus gamma d NQ plus 0.5 gamma b n gamma. That is for general shear failure. Now it is for local shear failure. So just consider 2/3 of C. C dash is equal to 2/3 of C and C dash plus gamma d NQ dash plus 0.5 gamma b n gamma dash. So take the value from the table. NC dash is equal to 11.8, NQ dash 3.9 and gamma dash is 1.7. For the phi is equal to 20 degree. So substitute the values. Once if you get QF, you can calculate QNF. What is that? I have told, in the last problem I have used in a different way. Now I am using this way. Okay, this is the simplest way. You can always use this method only. First find QF, ultimate bearing capacity. Then you deduct overburden pressure minus gamma D. That is net ultimate bearing capacity. So QNF is equal to QF minus gamma D. QF is 307.5 minus gamma is 18 into the depth of the foundation 0.8, that is equal to 293.1 kilonewton per meter square. Now you can find what is safe bearing capacity. That is nothing but, this is not QF, okay, this is safe bearing capacity QS. That is equal to QNF divided by factor of safety plus gamma D. Okay, this is QS. So substitute QNF is 293.1 plus divided by 3, factor of safety is given 3, then plus 18 into zero point 0.8. Depth of the foundation is 0.8. So you will get 112.1 kilonewton per meter square. So like this, you can calculate what is the safe pressure. Okay, first main thing you have to calculate ultimate bearing capacity. From ultimate bearing capacity, you have to calculate net bearing capacity. From net bearing capacity, you can calculate safe bearing capacity. Thank you.